let's talk a little bit about the pathway of blood flow through the heart. So now that we've gone through all of the anatomy, you know, all the parts and pieces, you know what the valves look like, let's talk a little bit about how the blood is moving through the heart. Now, you know from that little heart drawing that I showed you that we have a pulmonary and a systemic circuit. So we are going to go through these. We'll go through the pulmonary circuit and the systemic circuit. You've got all the words here. I'm going to show you this using this image. So we're going to start at the top left here. Okay, so you can see that, again, you know, we can draw that line down the middle of the heart. We are separating it into a right and a left side. Remember, the right side is going to carry all of the blue blood, the oxygen poor blood. So coming over here into the right atrium, we are going to bring blood from the superior vena cava, right? This is going to be draining the head, the shoulders, the arms, anything above the heart. The inferior vena cava is going to be draining all of that blood from below the heart. And then remember, we also have that coronary sinus that's going to be draining the heart muscle itself. So that spent blood is going to move into the right atrium. Okay, you can see that here. From the right atrium, it's going to move through the right AV valve. We also call that the tricuspid valve, and it's going to move down into the right ventricle. The right ventricle is then going to squeeze, and it's going to move through the pulmonary semilunar valve out into the pulmonary artery. Remember, it's an artery because it's carrying blood away from the heart. And this is going to take the blood out. Remember, pulmonary means lung, so it's going to take the blood out to the lungs. So here's that blood, it's coming into the lungs. We're going to fill it up with oxygen. Every time we breathe in, we fill our blood up with oxygen. And now we're going to take that nice oxygen-rich blood and we're going to bring it back into the left atrium. Okay, and we're going to bring it back through these vessels that are red. We have two on the left and we have two on the right over here, and those are our pulmonary veins. Now remember, what's coming into the atria are always veins, because veins bring blood toward the heart, and what's leaving out of the ventricles are always arteries, because arteries take blood away from the heart. And so that blood's going to come into the left atrium, and from there it's going to move through the left AV valve and down into the ventricle. The ventricle is going to squeeze, and that blood is going to move out the aortic semilunar valve and into the aorta. Okay, that blood is then going to go, that nice oxygen-rich blood is going to go out to your body's tissues. Your cells are going to go through cell respiration. They're going to use up that oxygen. They're going to create CO2 and lots of other wastes. And now we're going to start all over again. So there's that blue blood, and we're going to start all over again and go through the process again. Okay, so now that we've gone through all of the anatomy, we can add that into the pulmonary and the systemic circuits. Now, one thing that I do want to mention about the pathway of blood flow through the heart is that equal volumes of blood are pumped to the pulmonary and the systemic circuits. The other thing I want to say is that the pulmonary circuit going out to the lungs is a short circuit, meaning that the heart doesn't have to pump the blood very far because the lungs sit right next to the heart on either side. We also say it is a lower pressure circuit. There is not as much pressure and force behind the blood going out to the lungs. There doesn't have to be. So what we say is that the right ventricle, when it pumps that blood out to the lungs, it really doesn't have to pump very hard because the blood's not really going very far. Now we compare that to the systemic circuit, and it's a little different. The systemic circuit, remember, the left ventricle is going to pump that blood out to the systemic circuit, and that's all of your body's tissues, tips of your toes, top of your head. And so your left ventricle has to get a ton of pressure behind that blood. It's really got to squeeze to get it where it needs to go. And so what we find is that the wall of the left ventricle is a lot thicker than the wall of the right ventricle, because the left ventricle's really got to get that blood out to the systemic circuit. So it's pumping with a lot greater pressure. So this is an image that shows that. So this is actually a cross section through the heart. So we've divided it into a superior and an inferior half. And you're looking kind of down on the ventricles. And so you can see that this is our right ventricle. Here's that space over there. This is our left ventricle. And what I'm really wanting you to look at is the wall, the myocardium. And notice the myocardium around that right ventricle. It's there. There's muscle there. But in comparison to the myocardium around the left ventricle, it is much thinner. Okay, again, the reason for the difference is the pressure difference. Right ventricle pumps out to the lungs, and the lungs sit right next to the heart, so it doesn't have to go very far. We don't need much pressure. Left ventricle pumps out to the whole body, and so we got to have a lot more pressure behind it. So we need a thicker muscle to generate that force.